Okay, so you get it now. So for example, this is what we have done. If you expand this, we say we are going to get this, right?
Yes.
And we have used binomial expansion to also establish that we get the same thing. Is that not true? Now, we want to solve minus 1 upon x.
Sir. The reason did we stop at that place because the factorial was 2 or
No, we stop at here because the power here was 2.
oh,
Right? N is equal to 2. So we stop the expansion. Right? Good. Because the next one is supposed to be N, which is still 2. Do you get it? So that's why we stop at 2. So for this case, if we pass the limit, we are going to get 0 in the denominator. We don't want that. So what we are supposed to do, we are supposed to factor out x. And the only thing we can do here is to look at this particular expression. Right? 2x plus 1, right? Raised to power 1 over 3. Now, let's look at this one and see if we can use binomial expansion to work on just this one, which we can do. How? This can be written as 1 plus 2x, right? Raised to power what? 1 over 3, right? But say this is half. This is 1 over 3, which means we can use Taylor series or we can use binomial expansion to do this. But the only problem now is that it will be continuous. Right? You see, this is not an integer, this is. So first of all, if we are using this, let's compare again. We have 1. The next step will be what?
1 over 3 times 2.
So we have 2x. 1 over 3 multiply what?
2x over 3.
2x. Right? So we have 2x upon 3. Is that also? So the next one will be what? Plus what?
1 over 3.
Good. 1 over 3 into 1 over 3 minus 1, right? Upon what?
2 times. I'm sorry, 1 over 3 times 2.
2 factorial. Then how come now?
Oh, yes. Wait, what's so no? We have
2 factorial.
why 2?
Look at this is 1, this is 2, this is 3.
2x.
Oh, yeah. I just explained that. Right?
This is 2x.
So we have 2x, but now it will be odd. It's all the 2x.
And the 2x.
That will be squared. Is that also?
Yes, sir.
Oh,
sir. Is it because it's 1 over 3 that is not? Isn't it because it is square?
No. When you are talking about the factorial, you are considering the powers of u now, we said so now, u raised to power 1 divided by 1 factorial, u raised to power 2 divided by 2 factorial,
I'm saying this.
u raised to power 3 divided by 3 factorial.
Yeah, I'm saying this because of that's 1 plus x raised to the power 2. We stopped at 2 factorial plus x raised to the power because it's raised to the power 2, right?
Yes, but this one now you can't stop
Because
you just want to because of this half. You just continue. So in our case, we can continue. We can just stop at let's just do another one. Let's do another one. If we do another one, we left with what? 1 upon 3 into what? 1 minus 3 minus 1. Is that also? Yes. We still have 1 over 3 minus what? 2. Right? Upon what? 3 factorial. We are left with what? 2x raised to power 3. Plus, we just put 1, 2, 3. Can we put 1, 2, 3? That means it is continuous. Is that also? Is that also? Now, that means we have 1 plus 2x upon what? 3. But what are we going to have here? Let's put it properly. So we have. Is that so?
Yes.
Right? So here we are left with we can use cross multiply. I told you guys yesterday, right?
Yes.
So the answer here is 3. 3 goes here, we have 1 minus 3. So here we're going to be having what?
Minus 2 over 3.
Minus 2 over 3, which you can multiply. If you multiply with this, you're going to be getting what?
Getting 1.
So negative, first of all, this and this you have
Negative
2 over 6 over is this 6?
Yeah.
9.
Oh, yeah, 9.
Right? 2 over 9. What about here? Multiply
4x
what?
squared.
Yeah, 4x squared upon 2. So which means this 2 actually cancel this 2. Is that not so? Is that not so?
Yeah.
Good. What about this one? This one we're going to be having So we have 2, but here we're going to be having what? All over 27. Is that correct? 3 multiplied by 3.
Oh, 9.
Multiplied by 3.
That's
Here we're going to be having multiplying what? 8. 8x cubed upon what?
3 times 2, 6.
Upon 6. Fantastic. Right? But now, see where we're heading to. Now, remember the expression we have. Yes?
How many 2 come to that? That come that 2 come to that 6. We don't know.
No, this is what I answer. You can cancel this. But just remember, look at where we are going to. 2x plus 1 raised to power 1 over 3. You are supposed to take out 1 from it. So, can you see 1 here? So that means 2x, this solution is for 2x plus 1 all raised to power 1 over 3. Is that also? Now let's take out 1 from it. Can you see? So everything here minus 1. So therefore, 2x plus 1 raised to power 1 over 3 minus 1 will be equal to what? This one is gone. 1 minus 1 because everything here is minus 1. Do you get minus this one? So which means first of all 1 is gone. Right? Then secondly, you are supposed to divide it by what? By x. So which means if you divide it by x, you know 1 is gone already. So here will be what? 2. This place will not be what? 2 over 3. This place is going to be what? 2x. It's going to be minus 2x divided by 9. Divided by 9. Is that also? Then this place, whatsoever this place will turn to, this place will be reduced.
Inside to minus 4 to minus 4.
Are you sure that's 4?
That minus 2 times that 2.
So here it should be minus 4. Right? Even here, this place is going to be reduced. This x will now be x squared. Right? Now, when you now take the limit, what does the limit say? As x tends to what? 0. Which means you're going to pass the limit. If you pass the limit, anything multiplied by 0 will be what? 0. Here, there will be 0 here. Here, there will be 0 here. So the final answer will be what? 2 over 3. And that's that about that. Emmanuel, are we together? Let me explain it. Binomial expansion is used to expand expressions that look like this, especially when you can multiply them together. For instance, this can be very large number, so you can use binomial expansion. I will say that binomial expansion, the first term here is 1, the next term is n multiplied by u, right? Then you start using factorial representation. You now have 2 factorial in the denominator. You can see the factorial one increasing, right? Then here you have n into n minus 1. The next step, you have n into n minus 2. The next one, you add n minus 3 to your expansion. We now need an example. We say 1 plus x. If you decide to square it, if we decide to square 1 plus x, the expansion is going to be 1 plus 2x plus x squared. We now try it using the binomial expansion. The first term is 1, the next term is this multiplied by this 2x. The next term is 2 into 2 minus 1 upon 2 factorial multiplying x squared. Right? Now, 2 factorial is 2. 2 and 2 can go. 2 minus 1 is 1. So that's why we have 2 divided by 2. And then we have 1 plus 2x plus x squared. This is simple. Now, we have a question that says, take the limit of 2x plus 1. Let's equal 1 over 3 minus 1 divided by x. This is a big problem. First of all, you are supposed to take limit. Then, secondly, you can't factorize this. You can't expand this. What are you supposed to do? We use the same idea of binomial expansion. You get very important. So here, we just make it look like our original expansion, which is also here. So that we have 1 minus 1 plus 2x. Let's for 1 over 3. So the first step also is 1. The next step will be 1 over 3 multiplied by 2x, which is 2x divided by 3. The next step now is n into n minus 1. So we have 1 over 3 into 1 over 3 minus 1. This is 1. But because you can't just subtract fraction, we now say, okay, you can represent it as 1 upon 1, which is just 1. Right? Then you look for the SN, which is, if the SN here is 3, 3 into 3 is 1. Why 1 into 3 is 3? So when you multiply here, you have 3. So 1 minus 3 is minus 2. So if you evaluate what is in this bracket, you get this one. Right? Fantastic. So the next thing you're supposed to do is to do the second one, which is 1 over 3 minus 2. You do the same thing, you're going to get 1 over 3. After you have expanded, the question have subtract 1 from it. That is why we subtracted this 1 from it. So this 1 disappears. The next thing is saying divide everything by x, which means I will come to this my expansion, and anywhere I see x, I will cancel it. So that's why this x cancel out, there is no x here. This x cancel out, we are left with 1. This one over here, you will be left with x squared. Then you pass the limit. Now when you pass the limit, anywhere you see x, you're supposed to represent it by what? 0. So this particular term is supposed to be 2 over 3 minus 4 into 0 upon 9, if the expression is correct. Do you get it? But every other thing is going to be 0. Everything is going to be 0. So you're left with what? 2 over 3. Are we together? Good.